Hello, welcome to deploying HLS in a DO-254ED-80 workflow. My name is Byron Brinson. I'm the Mentor FUSA Field Technical Specialist for Mentor Siemens Business. HLS is a commonly used methodology to quickly develop, test, and deploy new algorithms in ICs. This typically utilizes a more software-oriented language for a higher level of abstraction. Due to the increased complexity of aircraft systems, avionics companies continually seek ways to deliver more robust functionality in their ICs in a cost-effective manner. Leveraging HLS is one of the ways to increase functional capabilities of IC designs without significantly increasing costs. However, some avionics companies find it a challenge to utilize HLS as part of a DO-254 workflow and need assistance regarding how to incorporate HLS and generate the required evidence necessary that demonstrates compliance to the DO-254 objectives. Given the advancement in verification technology, this paper provides an approach to use HLS as part of an overall workflow that complies with the overall DO-254 objectives, as well as provides the evidence necessary for acceptance by the certification authorities. Regarding the DO-254 objectives and the different life cycle phases, in planning, usage of HLS must be disclosed in the PHAT. It should identify the HLS workflow, artifacts that will be created, the processes utilized in the flow, and the DO-254 objectives that will be achieved. In the requirements phase, HLS requirement capture approach is very similar to traditional HDL. This means that artifacts generated will also be similar to the artifacts from an HDL flow. The conceptual design should provide the architecture and design description regarding how the hardware intends to meet the requirements. Not only can formats common to the HDL flow be used, but the HLS source code itself can be used if documented and commented properly. For detailed design, the HLS source code can be considered as the detailed design data. Standards, traceability, and reviews must be performed as part of the detailed design phase. Regarding implementation, the synthesis of the HLS source code into HDL is the implementation for this flow. Configuration and management of the artifacts from all these phases that is generated should be performed in accordance with the DO-254 objectives. And verification at the HLS level allows you to verify the design sooner, quickly, and identify deficiencies in the design. Below is a generic HLS workflow which shows it to be requirements driven as required by DO-254. However, while some formal verification is performed in this flow, there is not sufficient assurance regarding the output of the HLS synthesis. The enhanced catapult HLS flow provides additional design assurance. Design checks are performed in the HLS source code. Simulations performed with HLS source code as well as the HDL output after HLS synthesis. Sequential logic equivalency checking is used to formally prove functional equivalence between the HLS source code and the synthesized HDL output. In conclusion, it's possible to utilize HLS as part of a DO-254 compliant workflow. HLS working in concert with other tools can easily create the necessary evidence to meet the objectives specified by DO-254. And the Catapult HLS flow readily works with those additional verification tools to provide the evidence needed for a DO-254 compliant workflow. Thank you for your time.